So in this upcoming section, we're going to be asked to factor things that look a lot different. They're not going to be just quadratics anymore. We can't simply just draw a bunch of parentheses and try to multiply things out and guess that way. It's just not going to work. What we will be able to do is use synthetic division and guess some number and try and divide by that number. And if the remainder is 0, we'll know that what we divided by was a factor. But when we make our guesses, because it is just guess and check, we don't want to guess any random old number. We have this great thing called the rational zero theorem that'll help us figure out what numbers could potentially work. Just so in case you're not aware, when we say a rational number, we basically mean, like, to 99% of people in the world, that just means a fraction, like 2/3 or 7/5. But it also means numbers like 3 and 8 and -2. Any number that you can write as a fraction is a rational number. So like that would be a rational number, and so would this, because I could write that as 7/1. Just in case you're wondering, like, then what kind of numbers aren't rational? Well, square root of 2 is not really rational, because I can't write the square root of 2 without using that weird symbol. I can't just do that as a nice whole number over another whole number, or an integer over an integer. But so rational numbers are basically the numbers that you tend to think about when you think about numbers, including fractions. And the rational zero theorem says that if there is a rational number that'll make this expression equal 0, then it absolutely will be the case that the numerator will be a number that divides the constant, and the denominator will be a number that divides the lead coefficient. So it'll be of the form some factor of what divides the constant over some factor of the lead coefficient. So in this specific case, the possible rational zeros would have a numerator of 1 or 7, and it could be positive, it could be negative, and it'll have a denominator of anything that goes into 6. So that could be 1 or 2 or 3 or 6. And any way we can combine these numbers in a fraction, those are rational numbers that might make, when plugged in, might make this equal 0. So just to be clear, it's totally possible that none of the numbers that we generate will actually work. But it definitely is the case that if there is a number like that you might consider quote unquote normal that you can plug into here, and if it makes it equal 0, then it will definitely its numerator will either be 1 or 7, and its denominator will be one of these numbers. And the complete list is the thing that they show on the worked example. It would be 1 over each of these, plus or minus. So that's 1, that's a half, a third, it's a sixth. It's also -1, -1/2, -1/3, -1/6, and then it's 7 over 1, which I'm not going to write, I'll just write 7, or 7 over 2, or 7 over 3, or 7 over 6, or any of those negatives, or -7, or -7 over 2, or -7 over 3, or -7 over 6. Guaranteed, if there's some kind of number that you would be able to find with math that you knew in 4th grade that makes this equal 0, it's one of the numbers I just listed here. And it really is nothing more than the numerator is a number that goes into the constant, and the denominator is a number that goes into the lead coefficient. Factors of this divided by factors of this, when combined in every way possible, give you all the possible rational zeros. I'm willing to bet, but I'm not sure, that oftentimes Alex is not going to force you to resort to these weird fractions, and like when you're actually solving a problem, we could probably just stick with the numbers that are whole numbers, and those will usually get us what we need to get. Can't guarantee that, but I would put money on it. So, not that I bet, because that's unethical. But I'm just saying, if I were that kind of person, that's what I would do. All right, so if this does not make sense, look at a couple examples before you start panicking, because it's the kind of thing where when you hear it the first time, it's kind of weird, and then you just kind of get used to it. So let me know if there's questions, and good luck.